Hello and welcome to Y Slice afternoon sessions with me, Dr. Mike Brofchek. So in the afternoon, you're going to be able to interact with three different types of sessions. The first being an unplugged activity, followed by an activity related to microbits, and then finally a modeling activity using OpenJS CAD. So with that, let's get started to CS Unplugged with me. All right, so first off, our very first topic is actually going to cover algorithmic thinking and abstraction. It focuses on the Wyoming computer science domain of algorithms and programming, something that you would probably first try to do using some type of plug mechanism, but I want to show you that that's not necessarily required. So let's take a look at one activity. Pick any activity at all. In this case, I'm going to use setting the dinner table, or setting the table in general. Pretty broad, right? You could give this instruction to perhaps an older child or any adult, and they would be able to set the table. Might not be exactly how you expect it to be done, but in general, they could accomplish this task. But this one activity is actually many, many separate, smaller activities. So can we break it down? What are some tasks that you might have to do in order to set the dinner table? I'll give you a few moments to come up with a handful of potential tasks, and then we'll take a look at them. You can kind of get a sneak peek if you look to the right of the screen, but come up with a couple different activities. All right, so I know I didn't give you much time, but I'm assuming that this isn't an incredibly difficult task, but depending on what you've chosen as your activity, this could take a little bit longer. All right, so let's break down the activity of setting the table into some sub-steps. So clearly we have to clear the table. We have to get plates. We have to set plates. We have to get other items like flatware and glasses, and then we also have to set them. Perhaps with the glasses, we want to fill them, so we might have to get a pitcher of water and ultimately fill the glasses. So these are a whole bunch of steps, but by themselves, they don't actually accomplish the end task of setting the table, right? If I did any one of these individual tasks, it wouldn't lead to ultimately having a set table. So what we actually need is we need to start thinking about how we will take these subtasks and string them together in a way that in the end we get a set table. All right, so what I'm going to do is I'm going to start by clearing the table. If I did this later on, maybe I wouldn't get the expected result. So I'm going to start right there. Number one step is I'm going to clear the table up. Next up, I like setting flatware, so I'm going to do that. After I get the flatware, I could be bold and I could try to get other things. Right? Maybe I want to go get the plates, and then I want to set the plates, and then set the flatware. Right? I'm bold that I was able to pick up all those things and didn't think I would drop them. All right. So after I set those, I'm going to do this. I'm going to go get the glasses. It's my step 6. And I'm going to set the glasses. Step 7. 8. Getting a pitcher of water, because ultimately 9. I want to fill those glasses with water. And the end result then is, I set the table. I could redraw that picture, but in the interest of time, I won't. All right, I did not set the picture. I set the table. All right, so great. So in 10 steps, essentially, I have my original goal of setting the table. So that's a lot of steps, not a problem. And I could have come up with a different sequence and end up with a set table. So I have, how many blocks did I have there? How many tasks? Well, 1, 2, 3, 4, 5, 6, 7, 8. I used 9 blocks to accomplish this. And how many arrows, how many actions? Well, I also had 9 actions. So 9 blocks, 9 tasks, 9 arrows, 10 if you include the final one, to set the table. The question is, can we be more efficient? Not necessarily a number of steps, but there's a lot of repetition here. I had to draw a lot of different blocks. So that means there's a lot of repeated actions that I'm doing. And so one of the fundamental things that we look at doing in computer science is we try to abstract this idea around. I'm doing a lot of getting and a lot of setting. So what if I refine, so we'll call this a refinement of my activity. What if I refine my activity slightly? All right, clearing the table, perfect. But I am doing, like I said, a lot of getting and setting. And here are the objects that I'm getting and setting. I'm getting plates, flatware, cups, and pitchers. If you go back and you take a look, those are all the things I was getting. And I was setting a lot of those. So what if I created a block called get the object? And that object is just some table item, right? And these up here are table items. There are 4 of them. So I can get some random object, and then instead of having to say set cup, set flatware, I could say set object, and I use that little cloud symbol again. And then maybe I want to be even more specific. Instead of being so open-ended and just setting it, I want to actually pick a location on the table to set it. So let's take a look here. So we could get it, set it, and then we're going to show you what these last 2 blocks do. But if I was going to use this new updated version, let me make sure you can see all of the blocks at once. So we would start off with this new set of blocks. Notice that there's 1, 2, 3, 4, and we've repeated this block down here, 5 blocks, but you could actually do it without it. But let's see what this would look like. We start at the same place, and then I would draw an arrow to get a table item. So my second step, if I was going to do exactly the same thing I did last time, step 2, I would be getting, what did I get the first time? I got the flatware last time. So I'm going to get the flatware. And just so that I'm not as silly here, I'm going to now set that flatware. So 3 is a set. What am I setting? I'm setting the flatware. And where did I set it? If I'm matching what I did before, location 1 and 3. That's where I did that. Now, in order to maintain the same kind of model that I did before, I now need to get something. So I'm going to go back here, and I'm going to do a get. So this is step 4. And what am I getting? I'm going to get the plate. And then step 5, I'm going to set the plate. And again, location 1 and 3. And that could be even more specific, right? I mean, within each one of these places on the table, there might be a specific location that I want to set it in, right? You don't want to stack everything on top of one another. And I would do this again, and go back, and step 6 would be the cup, and step 7 would be setting the cup in location 1 and 3. And then I've broken it out, but I could have gone back, but I could do step 8 here to get the pitcher, and step 9. Basically, we're using the pitcher to fill the glasses. So, same number of steps, 9 of them, but really we only used 1, 2, 3, 4 unique blocks, 5 blocks total. Since this get one we duplicated, but we only have 4 unique blocks as opposed to the 9 unique blocks that we had last time. All right, so this is basically the idea of abstraction. We abstracted the idea of getting and setting into something that is much easier to represent, and I don't have to spend a lot of time redoing the same action or defining it over and over again for each new item. All right, so now let's take a look at some control in here. We did something that was very linear. It just went straight through. It was very, the process had no choices. So let's focus on one particular thing, the last part of our setting the table. In the last part of setting the table, we got the picture, and we had basically getting the picture was our 9th step, and then we filled the glass. So question is, what happens if the glass is already full, right? Or what if it's not empty? What happens? What if the pitcher is empty or full? So we actually want to make some choices based off of these things, right? That's what we would do in real life. So we could actually draw these new blocks. So here's one that basically has a glass and a question mark, and is it empty or not empty? And then we might do something in our flow based off of one of these. Same thing with the pitcher, empty, not empty. How might we have used this in our 9th step? Well, maybe the 9th step, instead of just getting the pitcher and filling it, maybe it actually starts with that question, right? So maybe the 9th step actually says, hey, is my glass empty or not empty? If it's empty, then I'm going to go get the glass. That's good. And then I need to go look at the pitcher. If it's not empty, I can fill the glass. Right? So clearly we might need some new tasks here that we might have to generate based off of this logic. Right? We might need to have something that actually fills the pitcher. So we might need to have some task that does that. But we can start introducing some decision making. Okay, so for those of you that have noticed, those two blocks of checking if something was empty or not empty, we could have made into, this more abstract block. We don't really care if it's a glass or a pitcher, or perhaps the table or a plate, right? We just want to be able to differentiate between something that's empty and not empty. And so I could have replaced these with one block like this, and made things a lot cleaner and maybe a little bit more robust. A lot stronger, we could deal with decisions that might have to happen when setting the table. All right. Now the other thing that was a little bit messy in our previous view of the world was the back and forth that we had to do every time we got an object and setting an object. We were repeating that flow, right? We were repeating two tasks over and over again in the same way. So maybe I could come up with a way to show repetition. So I have this item, this green little unknown, and it is going to get used inside this block 2 times. We're going to get it and we're going to set it. And so what are we going to do? Well, we're going to do that to plates, flatware, and cups. So for these 3 items, I want to get it and set it. Maybe what I have to do is I might also have to specify where I want to set it. So maybe instead of just specifying the object, I might also want to specify a location, right? So maybe I could do that in here as well. I could do pick a number, right? And then I could also say the number equals 1, 3, something like that. This isn't so much important in terms of what this looks like. You just finding a way to represent this repetition, this idea of repetition is really important. So we're abstracting away the fact that there are sequences. The last time we abstracted away that multiple objects had, we're doing the same thing, we were getting the same object over and over again. This time what we're abstracting out is there's a process that's being applied, that we want to show that we are getting and setting these objects. So there's 2 levels of abstraction here. All right, so now it's your turn. I would like you to basically come up with your own task from a lesson, daily life, your choice. And what you're going to do is you're going to start off basically doing that multiple panels like we just had. You're going to draw one image and write one sentence for the overarching task. And then I want you to convert it to a basic set of stages or subtasks and sentences for each. After you do the subtasks, I want you to draw a flow or a path through all those tasks. numbering them. Thinking about if there's other ways that you could do that. Number them differently, order them in a different way. What happens if you misorder them? And then I want you to apply refinement. Try to simplify the total number of unique tasks that there are. Maybe through the application, like you saw before, of something that can be applied to many, many different things. So in our example, it was getting and setting. Those are common actions that we can apply to many different things. So I want you to apply that refinement to your activity and draw a new panel. And then optionally, it'd be really nice if you could try to add in some controls. So can you add in some of those decision-making processes? Are there things that are being repeated? Can you simplify your overall flow, your overall activity to simplify it, but yet still accomplish this complex task? All right, so can't really do this during the session today, but try to share that updated flow, your final flow, with the decision-making and controls and simplified view with somebody else, maybe tonight, and ask them to complete the task as you've written it and drawn it with no help from you. So can they do it? What happens? That might lead you to some insights in terms of how precise and how much you might need to include in these. Okay, and then with that caveat here though, how much information do we as adults and as humans in general fill in based off of our prior knowledge? These are things that we might do, but we can't assume that, for example, a computing system would do. I've kind of already alluded to this, but is there only one way to complete a task? Is that still the case in number 9, even if all the subtasks are the same? And then we get to the fun one here. How would you design a robot to do the task you've selected? What features, what capabilities would your robot need to have to do this task? Think about the one that we just saw. What would you need to have a robot be able to do? Well, you need to be able to get and set for my robot. What does that mean in terms of gripping and all the things it might have to do? If a robot's going to do it and it's no longer a human, what might you need to change or create? Do you need to create new subtasks? Might you need to come up with alternatives if the robot didn't understand something? So with that, I'm going to let you go and attempt to do these. Take a look at the written instructions that are basically a copy of these, and we'll see what you come up with. Thanks.